Hello, welcome back. So, vectors is a topic that is covered a bit in math, in O-level math, and it is further expanded in O-level Addmath. So, I'm expecting that you already know the basic stuff. You already know the notations, such as the fact that this thing, A, B, and an arrow above it, let's say this equals 5, 7. Actually, just check 4, 3. Right, you should know that this really means that A, B, and this arrow means that this is a vector that goes from A to B, and in going from A to B, it covers 4 units horizontally and 3 units vertically. So if I draw a grid, let's say A is over here and B is over here, right, this is the vector AB, and this is represented by moving 4 units over here and 3 units over here, right? And you should also know that, let's say there's this vector A which looks like this, and this vector B which looks like this. Now A plus B really means that first you follow the vector A, and once you land from the point where you land, you follow vector B, right? So you started from this point, this starting point, and then you ended up over here. So this is A plus B, if this is A and this is B, right? Furthermore, you would also recall that if this is some vector A, then minus A is the same vector but it's pointing in the opposite direction. So if I want to find A minus B, I can think of it as A plus some vector which is minus B. So I want to add two vectors, one of them looks like this and the other looks like this. So it will basically be, first I follow A and then I follow B, and then I get to the same point, and then I get to some point, and this is A minus B. This is A, this is minus B, right? And of course they follow the same calculations. Say if I do A plus B, and let's say if A is 4, 3, B is 5, 6, then you simply add these two, and this would give you 9 and 9, right? So A plus B is equal to this vector is 9 and 9. Now one thing is that, let's say if I tell you that AB is some vector 4, 3, right? Here you know that what I mean by this is that in order to go from A to B, you have to move 4 units vertically and 3 units horizontally. Another way that we can represent this, let's say if we have some plane, what we can do is we can define two vectors. So one vector will be on the x-axis and another vector, let's say like this, will be on the y-axis, right? And so for our convenience, we can say that both of these, what we call basis vectors, both of them will be 1 unit in magnitude, just for our convenience, right? And by convention, we have chosen that on the x-axis we have the I vector, and on the y-axis we have the j vector. So if I want to represent this thing in terms of I and j, well, we can see that we need to move 4 units in the x-axis, right? So what I can do is I can take my basis vectors, that is I, and I can repeat this 4 times, right? That would be the same thing. So the point is that I can represent this in terms of basis vectors I and j as 4i plus 3j. It's the same thing, because vectors will keep on adding to give the same result. Also, since we talked about basis vectors, we can also expand to what is called unit vector, right? So let's just take the same example, that is AB. So if I know that this is some point A, or actually let me say that OA is 4, 3, right? So this is O, this is some A, right? And I'm going from O to A. First I move 4 units like this, and then I move 3 units like this, and so I land up at A, right? But let's say this OA has some magnitude, it has some length, right? And I want to find a vector that follows the same direction, but its magnitude is only 1 unit. So we know that if AB is let's say 4i plus 3j, then we can find the magnitude, which is represented by this. We can find the magnitude simply using Pythagoras' theorem. If you have any x and then y, you just need to find this length. And so this length, let's say, is some p. So p squared will be equal to x squared plus y squared, and then you can square root this. And so we see that the magnitude of AB will be 4 squared plus 3 squared, and this turns out to be 5. Right, so we now know that sorry, this should be OA, we changed it. Now we know that this has length 5, right, and a unit vector follows the same direction. So we know that its direction will be some fraction of 4i plus 3j. And so if the total length is 5 units, if we divide this thing by 5, then we'll get the unit vector, right? This is the unit vector, right. The reason why we care about such a vector is because it can be useful in a lot of things, right? Because knowing the direction is essentially one part of defining a vector. A vector is defined by its direction and its magnitude, right? So let's just do one worked example from the book, worked example number 3. And it basically says that if you have one vector a, let's say it is minus 2i plus 3j, and then another vector b, it is 4i minus j, and then there's some other vector c which would be minus 22i plus 18j. And the question asks that there's some lambda times a plus some mu times b equals c, and we have to find lambda and mu. So the gist of the question is that there's some vector like this and maybe some other vector like this. I'm just giving you an idea, and we know that the some combination of these two will give us the vector c, right? Some multiple of a plus some multiple of b will give us c. We need to find out what is that multiple exactly. If we plug in our values, lambda times minus 2i plus 3j will give us mu times 4i minus j, and this should equal minus 22i plus 18j, right? If we expand this, minus 2 lambda I, and then I will write the other I, plus 4 mu I plus 3 lambda j minus mu j should give us minus 22i plus 18j. Right, in order for this equality to hold, both the I component and the j component should match. So the I component is defined by minus 2 lambda plus 4 mu, and this should give us minus 22, right? So this is one equality that must hold. The other one is that 3 lambda minus mu should give us 18. This is the other one. And so we can simultaneously solve them, and you will get to the conclusion that lambda is equal to 5 and mu is equal to minus 3. Now essentially this is sort of all there is to vectors, because everything else is some way or another a combination of what we've already seen, right? So for example, here we saw that a plus b equals what a plus b means. And so if I were to tell you that, okay, so let's say there's some vector OA, that means it takes you from O to A, and then I add some other vector AB to it, so this vector takes me from A to B. Now this should equal OB, right? And so I can continue on that OA plus AB plus BC equals OC and so on. But this is the general idea, that if I have any vector PQ, then I can maybe find some intermediate, let's say px plus xq, and both of these would be the same, right? The general gist of it is that if you want to go from this point to another, it doesn't matter if you go over here first and then here, because you're ending up at the same point, right? And so let's go ahead and try to do worked example 4. So I have imported here worked example number 6 from the book, and let's try to solve it together. Now, if you look at part A, it first asks us what is, we need to find BA in terms of A and B, right? So we are going from B to A. Now we know what this root is, we also know what this root is. In other words, we can use O as a pivotal point, sort of. We can use O as an intermediate to form our equation. So BA should be the same as BO plus OA, right? BO is minus B, OA is defined as A, and so this is our answer. Next, it asks us to find bx. Um, well, bx is just 3 over 5 times ba. We already calculated what ba is, so this should be 3 over 5 times minus b plus a. And then we have to find ox, right? So we know bx and we also know ob. We can use this. So ob plus bx, we know that ob is just b plus bx is 3 over 5 minus b plus a. This would be 3 over 5a minus 2 over 5b, plus this should be a plus 2 over 5b. And then lastly, it asks us to find by. Well, this would equal bo plus oy. Bo is just minus b, and oy is defined to be 3 over 4 times oa. In other words, 3 over 4a. OP is lambda times 3 over 5a plus 2 over 5b, and also OP is equal to mu times by would be minus b plus 3 over 4a, and we need to find the value of lambda and mu, right? So since both of them are OP, they need to be equal. So 3 over 5 lambda a plus 2 over 5 lambda b should equal minus b mu plus 3 over 4 mu a. Sorry, wait, this is wrong. So OP will be it will be equal to OB plus BP. OB plus BP, right? And they have defined BP to be mu times some by, right? And this is B, so this should be equal to B plus mu 3 over 4 a minus b. This should be equal to 3 times mu 3 over 4 times mu a plus 1 minus mu b. So we can equate both the a's and the b's. So 3 over 5 lambda should equal 3 over 4 mu. In other words, 4 lambda equals 5 mu. This is one part. The second part would be equating the b component. So 2 over 5 times lambda should be equal to 1 minus mu times b. So we can cross multiply that 2 lambda is equals to 5 minus 5 mu, right? So again we have two equations using two variables that we need to find out. We can solve them simultaneously. So lambda would be 5 over 6 and mu would be 2 over 3, right? And we are done. So one last bit that we are left with is sort of the practical aspect of this. So vectors are widely used in physics, and they can basically be used to denote things like velocity, right? They can be used to denote any vector quantity. So the ones we work with are basically displacement and velocity, and the basic rule is that you might remember that speed is distance over time. By the same logic, vector is displacement over time, right? And displacement is basically the initial position that we can say is p plus uh, times multiplied with the velocity, right? So displacement is basically you start at some point plus you're moving at some velocity. It says that at the time 12, a coast guard at point O observes a ship with position vector 16 and 12, right? So the starting position is 16, 12 relative to O. The ship is moving at the steady speed of 10 kilometers on a bearing of 330 degrees. So bearing is always clockwise. What they're really saying is that it's moving such that this much is 30. So if I make a horizontal line, this would be 60, and the length of this line, which represents the velocity, is 10. So in part A, they tell us that the velocity is minus 5p. In other words, we know that the x component is 5. We need to find the y component, which is p, right? You can do this from a lot of ways. You can do the Pythagoras theorem that p squared will be 100 minus 25, or you can even do that p would be 10 times cos of 60, 10 times sine of 60, So P will turn out to be 5 root 3. Right, so our position vector is 16, 12, and we are moving at the speed of minus 5 and 5 root 3 kilometers per hour. Right, so also this was 10 because speed is basically the magnitude of vector. So if I have any vector that is changing its x and y's by some value, the speed will be the magnitude of this. In other words, it will be x squared plus y squared and the square root of this. Right, it will be the length of this. Right, so part B asks us write down in terms of t the position vector of the ship relative to O t hours after 12. So it starts at 1612, right, and then it is moving at this certain velocity, and so we can do initial displacement plus the change in displacement, which is velocity multiplied with time. Right, so this would be our answer. And part C is what find the time when the ship is due north of O. So if something is due north of O, then that would mean that it has, if we look at this diagram, that would mean that it has no x component in its displacement. And so displacement is given by 16 minus 5t and 12 plus 5 root 3t. Right, we want 16 minus 5t to be equal to 0. This will happen when t is equal to 3.2. So we start at 12 and we need to add 3.2 hours to it. It would be equal to 12 here. This would be 15, 12. So at this time the ship is due north. Right, and the last part says find the distance of the ship from O at this time. So S would be equal to, well, 16 minus 5t would be 0 if we input 3.2, so this is 0, and then we have 12 plus 5 root 3 times 3.2 because this is the time. This would equal 0 and 12 plus 16 root 3. Right, and so, well, actually this is your final answer, but if you had any number here, the way you would do is that you basically know the x component and the y component. You need to know this thing. So it would be x squared plus y squared and the root of that. So square root of 0 squared plus 12 plus 16 root 3 squared, and this would turn out to be 39.7 kilometers. Right, the reason why we are taking the magnitude of the resultant is because they ask for distance rather than displacement. And this is all there is to it.